State the name of the process that occurs as the wave passes into the shallow water. Refraction. 3. Complete Table 6.1 to state whether each of the properties of the wave increases, decreases or stays the same as the wave passes into the shallow water. Wavelength, decreases. Frequency, stays same. Speed of wave, decreases. 5. A. State the name of the reflection of a sound wave or ultrasound wave. Echo. 3. State whether the image formed by the mirror is virtual or real. Explain your answer. Virtual, no mark. And cannot be projected on a screen / light doesn't pass through image. B. We can see light from the sun but we cannot hear any sound from it. State the reason for this. Light does not need a medium to travel through. Sound needs a medium to travel through and there is no medium between sun and earth. Explain, in terms of the wave fronts, why the light changes direction as it enters the solid. You may draw on Fig 6.1 as part of your answer. Idea of one side of wave front enters / hits solid first or wave front does not all hit the solid all at once. Idea of the side slowed down first or the side delayed relative to other side. Angle of wave front changes or different parts of wave front delayed by different amounts. Suggest a cause for the change in direction of the wave. Waves move faster in region B or slower in region A. A train travels along steel rails. A person waiting at a station hears the sound of the train through the rails before he hears the sound through the air. I. Explain why this happens. Sound travels faster in steel / metal / solid / the rail than in air. I. Describe the position of the object in relation to the lens. Object closer to lens than one focal length. 2. Describe the position of the image in relation to the lens and the object. Image same side of lens as object. Or image further from lens than object. 3. Give 3 properties of the image formed by a magnifying glass. 1 from 3 of, image enlarged / magnified, upright / goes up, virtual. All 3, image enlarged, upright, virtual. State the speed of radio waves in air. 3.0 times 10 to power 8 m/s. Sound waves are longitudinal waves. Describe how a longitudinal wave differs from a transverse wave. Longitudinal wave vibration direction parallel to propagation / energy travel direction. Transverse wave vibration direction perpendicular to propagation / energy travel direction. Consists of rarefactions and compressions. State a typical value for the speed of a sound wave in water. 1500 m/s. Describe and explain 2 ways in which a diagram representing the wave with the greater frequency differs from Fig 6.2. Compression / rarefactions closer or more compression / rarefactions in same distance. Less diffraction / spreading out because of smaller wavelength or ratio wavelength / gap width smaller. Another harbor has a much wider gap between its walls. Describe and explain how the pattern of wave crests in this harbor is different from the pattern you have drawn in I. Waves pass through gap remaining straight. Less / no diffraction occurs. State 3 properties of the image I. Real, inverted and enlarged. D. A student incorrectly states that this lens is being used as a magnifying glass. I. State how the image produced by a magnifying glass is different from the image I. Image produced by a magnifying glass is upright, not inverted or virtual. Describe what happens to the light after it passes through the lens. All the light meets at a point or is focused or intersects. All the light travels towards a point. It then diverges or spreads out from that point or point of convergence is on XY / at F / the focal point / principal focus / 3.0 centimeters from lens. State and explain whether I is a real or a virtual image. Virtual and light / rays do not pass through I or virtual and light / rays only seem to come from I or virtual and produced by diverging rays. Virtual and real rays do not meet. 3. State the name given to a lens when it is used in this way. Magnifying glass. 0625_S22_MS_42.pdf. 5. Sound waves are longitudinal and electromagnetic waves are transverse. A sound wave used for a medical examination has a frequency of 1.5 MHz. State and explain what type of sound wave this is. Ultrasound or sound frequency above audible range. Frequency 20 kHz or 20,000 Hz. State one feature of a virtual image. Not an intersection of rays or cannot be formed on a screen or cannot be projected on a screen or light rays do not pass through image or light rays do not meet or light rays do not converge. B. Describe one use of X-rays in medicine. Basic description of use, e.g. X-rays for detecting broken bones. Additional detail, e.g. X-rays pass through soft tissue and not through bone. B. State two ways in which transverse waves differ from longitudinal waves. Any two from. Particles in transverse waves vibrate perpendicular to the direction of travel of the wave, or particles in longitudinal waves vibrate parallel to the direction of travel of the wave. Longitudinal waves have compressions and rarefactions. Transverse waves have troughs and crests. C. State a typical value of the speed of sound in water. 1000 m/s value 2000 m/s. 2. Explain why sound travels faster in water than in air. Molecules closer together / water has greater density. B. State two properties of the image formed by the mirror. Any two from. Virtual. Upright. Same size as object. Laterally inverted. C. Visible light is an electromagnetic wave. State the name of one region of the electromagnetic spectrum in which the waves have shorter wavelengths than visible light. Ultraviolet / X-rays / gamma rays. 2. Longer wavelengths than visible light. Infrared / microwave / radio waves. 0625_S23_MS_41.pdf. 5. Fig 5.1 shows a block ABCD made of glass that has a refractive index of 1.5. The block has one curved side up and three straight sides, BC, CD, and D. There are right angles at C and D. The curved side up is 1/4 of the circumference of a circle that has its center at point P. A ray of monochromatic light enters the block through the curved side up and strikes side BC at P. Some light emerges into the air and some is reflected. A. State what is meant by monochromatic. Light / electromagnetic radiation of a single frequency. B. Explain why the ray of light does not change direction when it enters the block through side of. Angle of incidence /I equals 0 or incident ray along normal. Or all of wave front enters block at same time. Angle of refraction /R equals 0 or no refraction. Or whole wave front slows down at same time. D. Fig 5.1 shows that the angle between the ray of light and line AP is theta, where line AP is at right angles to side BC. Angle theta increases to 45 degrees. State and explain what happens to the light that strikes P. All light is reflected. Theta / angle of incidence C / critical angle. 2. When theta equals 45 degrees, the reflected light strikes side CD. Describe what happens when this reflected light strikes side CD. All light is reflected. Or reflected ray at 90 degrees to incident ray. Or reflected ray is parallel to original ray. B. State two reasons why microwaves are used for mobile phone, cell phone, signals. Microwaves only need short aerials / antennas. Microwaves penetrate some walls. C. All mobile phone, cell phone, networks use digital signals to communicate with the phone. Describe, with the aid of a diagram, how a digital signal differs from an analog signal. Labeled diagram of digital signal with blocks of high 1 and low 0 and labeled diagram of analog with continuously. Variable signal. Digital signal consists of two values. Analog signal varies over a range of values OLL. 2. State 2 advantages of using digital signals rather than analog signals. Any two from. Faster data transmission rate or data can be compressed. Data/signal transmitted over longer distances as signal can be regenerated. Noise easily removed from signal/data or signal can be regenerated. B. State 2 reasons why microwaves are used for mobile phone, cell phone, signals. Microwaves only need short aerials/antennas. Microwaves penetrate some walls. C. All mobile phone, cell phone, networks use digital signals to communicate with the phone. I. Describe, with the aid of a diagram, how a digital signal differs from an analog signal. Labeled diagram of digital signal with blocks of high 1 and low 0 and labeled diagram of analog with continuously. Variable signal. Digital signal consists of two values. Analog signal varies over a range of values OLL. 2. State 2 advantages of using digital signals rather than analog signals. Any two from. Faster data transmission rate or data can be compressed. Data/signal transmitted over longer distances as signal can be regenerated. Noise easily removed from signal/data or signal can be regenerated. 0625_S23_MS_42.pdf 62 types of seismic waves are P waves and S waves. A. State the types of wave that P waves and S waves can be modeled as. P waves, longitudinal. S waves, transverse.